right, looks like we've gotten something back resembling an internet connection. So hopefully this will hold out. So I've already answered one question via the chat. And the question is there any way that we can, first question being, is there a way to view which questions you got wrong on the exam? And the answer is yes, now that the exam has passed. The reason being that we have had issues in the past of students using Chegg. So basically, actually, we still have issues of students using Chegg, where they will post their test results to Chegg, and this gives other students the ability to look at the exam and discuss it and figure out what the answers are before they take it. Now, I also got just asked a question about curving exams. We do not curve exams at Wake Technical Community College. We're actually not allowed to. So the score you receive is the score you receive. Now, that said, we do have the ability to kind of dial these exams in throughout the semester. So if the average is below where it should be, the exams will probably get easier as we go along. Also, one thing to keep in mind, these courses are front-loaded. Between now and the final, this is going to be the first exam is going to be the hardest exam you take. And then from here on out, they're going to get subsequently easier into the final. And the final is only hard because it covers a whole bunch of material. So I would say if you were able to get at least a C on this exam, you should be sitting pretty well for the rest of this course, as long as you kind of keep up with material and keep up with asking questions. But again, we don't curve. We're not allowed to curve. This kind of creates a lot of issues with grading, and there's a lot of good reasons why you shouldn't be curving. Now, I did get one request this morning to answer a test question, and this was for the Orgo 2 folks, and the question was, one of the examples they were given were 4 molecules. Oh boy. Nope, definitely negative there. And we're asked to determine which of these pairs were aromatic compounds. Now, as we talked about in the discussion board, 3 things you want to go through to figure out if compounds are aromatic. Now, the test question here was a lot easier than what you saw on the discussion boards. The first one is it cyclic? These are all cyclic. Are they conjugated? Every single one is conjugated. So this leaves you now with the 4n plus 2 rule. So they have to obey this 4n plus 2 rule. Yeah, you're welcome. You have to obey this 4n plus 2 rule in order for these compounds to be aromatic. So if you look at this one, any positive charges, unless we have a lone pair, we're not adding electrons. Double bonds count as 2 electrons. So here we have 2, 4, the cation is 0, so there's 4 electrons. And we cannot get this to equal 4n plus 2. For this one, we have 2, 4, 6 electrons. That's definitely 4n plus 2. Here we have 2. So in this case, if n equals 0, we meet the condition of 4n plus 2. Now, process of elimination is a terrible way to do this because you could have been wrong about one of these. But if we look at this, 2, 4, 6, 8 electrons, and this does not equal any value of 4n plus 2. So in the case of the example it's showing me, the second and the third are the aromatic compounds. And again, this is easier than the discussion board because the discussion board I made you first go through, are they cyclic, are they conjugated? If they don't look conjugated, how can you make them look conjugated? All these compounds met the first 2 criteria. It was just a matter of you counting up the number of electrons. Other questions from the exams? I did get 2 other questions. I answered them in an email, but I can answer them here for Orgo 1. One was concerning which compound has the largest chemical shift relative to TMS. That TMS is kind of distractor information. In NMR, we have reference solvents. I don't really talk about them that much because it's a lot of information to process with NMR. I'd rather you focus on the theory, but you didn't even need to know what TMS was to answer that question, or you didn't have to know what the solvent was to answer that question. What you're looking for with most shield is an atom. In the example that was given was carbon-13. It's an atom that has as much electron density pulled away from as possible. So I think you were given methane, CH3Cl, CH2Cl2, Cl4, things like that. The one with the most electron withdrawing groups around the carbon would have given you the most deshielded. The other question, which was also a fair question. So the TMS you need to know, I'm saying it has something to do with symmetry. Unfortunately, I moved that email out of my inbox. Give me just a minute. Oh, the one about there was a polarimetry question. The particular example that was given was if you're given a compound that has an optical rotation if it's pure, what happens if if you've got a 75-25 mixture? Well, you just calculate the EE in that case. In this case, it ended up being 50%, so it was pretty straightforward math to figure out what since it's EE of 25% or EE of 50%, the optical rotation would have been half what it was to begin with. For dimethoxybenzene, so question just asked for the foreign lab report, what is the reaction written out for dimethylbenzene? It doesn't do anything, so there's no reaction for dimethoxybenzene. It's the compound that stays consistently in the organic solution. So that's all you have to say is that it didn't react with the base, it didn't react with the acid, so it did nothing. Come here. I mean, there are reactions to dimethoxybenzene, but you didn't run any. How the reaction of AlCl3 works with a primary alkyl halide. So when we have AlCl3, and I'm going to draw out a primary alkyl halide, what will end up happening is that this chlorine is actually abstracted by the AlCl3, and so we end up getting AlCl4 minus plus this carbocation. So all AlCl3 reactions with alkyl halides, and for those of you listening, this is Orgo 2, they're going to go through a carbocation. So this is why if we have a primary alkyl halide, we actually end up getting rearrangement. So in this case, we get a hydride shift, and we will produce the secondary carbocation because it's more stable. Now, this is why if you want to attach a primary alkyl halide, what you're actually going to have to use is an acyl chloride. And the acyl chloride doesn't rearrange. We don't get this carbocation rearrangement. And this will be what we end up reacting. And then we have to use something like a Manzinga reagent or some type of compound that will reduce off that carboxylic acid. But the short answer is AlCl3 will form a carbocation, and then with primary alkyl halides, you get carbocation rearrangement. And the most stable carbocation is typically what you attach to the benzene ring. That was also alluded to in the discussion board because you had a reaction where you were trying to add a primary alkyl chain to a benzene ring, and you had to go through the acyl chloride in order to do it, and then you had to further reduce it, whereas the one where you had it like a tertiary alkane that was attached to the benzene ring, that one you could do directly. Looking through the Orgo 2 exam right now. That was actually a pretty good exam. Hey, you're welcome. I do shy away from the mechanisms when metals start getting involved because this is a really oversimplified look at what's going on. So the inorganic and chemist in me gets really frustrated seeing that, but I also understand that there's that trade-off between understanding it and... So last week's discussion board is a recap for Orgo 1. So let me bring up the discussion board, and this is for the polarimetry. So I intentionally picked something that I didn't want you looking up. So there are formulas given that use both decimeters and centimeters, so let me bring up the notes. Analysis of organic molecules. So I want you to stick with a formula that uses centimeters. The big reason I want you to do this is that centimeters is a far more common unit. Decimeters are kind of how they used to be set up to do it because they always came with standard 10 millimeter tubes. Now I corrected the notes. It should be bracket alpha equals alpha over CL. So you were given the alpha, or no, you were asked to find the alpha. So we got 0.3 grams of cholesterol, and it's in 15 mLs of solvent. And we have a path length of 10 centimeters. And we end up getting a rotation of minus 0.78 degrees. So all of this just kind of plugs into this formula. Your concentration is 0.3 divided by 15. Your 10 centimeters will plug in. So there's your concentration. Wow, that's really nice easy math. 0.1 over 5. So concentration is 0.02. Your path length in this case is going to be 10. Your alpha is the unknown, and your rotation is minus 0.78. So you end up getting something like 3.6, or no. You end up getting a pretty simple number. Now again, it was intentional why I did this one. I wanted to make sure that it wasn't a number. So if you just try to look up what this number was, you wouldn't get the number that it actually is. This is mostly to make sure that you're still kind of working with the formulas, making sure you're actually working with the formula, not just looking this stuff up in tables. But that's it. You just plug and chug into the formula that's on the notes on the course website. So number 11. So number 11 for me is which of the following compounds are orthopara-directors. So if you're asking, oh, I think it also gives it to you in randomized order too. Hey, you're welcome. So if it's like the one I got, which was number 6. So for me, number 6 it gives me 4 compounds. They're all cyclic and they're all conjugated, and it asks which of the 2 pairs are aromatic. Basically, you just go through and count the number of lone pairs because they already meet our first 2 conditions. They're cyclic and they're conjugated. And every time you see a double bond, you add 2 electrons. Every time you see a lone pair, you add 2 electrons. Every time you see a plus, it's 0. And as long as it follows that 4n plus 2 rule, then they're aromatic compounds. Also, are you asking why I would randomize the questions just to make it that much harder for y'all to cheat? Although the Orgo 2 folk did really well in their exam. Really impressed. Actually, the grades were pretty one in Organic 1 as well. So again, the question about which the two are aromatic, this was the example I was given. Again, they're already cyclic, they're already conjugated, so really the only thing you do is start counting up electrons, and if it obeys that form plus 2, so it's 2, 6, 10, 14, 18 electrons, then they're aromatic. Much easier and nicer than the one I gave for the discussion boards. Oh, no, this is why we're here. So if we look at the third compound, it's conjugated, so for every pi bond we're going to add 2, and for every carbocation we're going to add 0. So if we do the 4n plus 2, if n is 0, then we meet this condition that we've got 2 electrons. So this cyclopropene carbocation is actually the simplest example of an aromatic system, although it's not the most practical example, which is why we typically stick to benzene, because that's the more popular example. So yeah, you've got the 2 electrons from the double bond, you don't have any of the carbocation, and n can be any integer from 0 to infinity. So as long as we have something in there, if we put 0 in there, we're going to end up with 2. Does that make it a little bit clearer? Hey, you're very welcome. Again, the point of this is to clarify. So if you have questions, feel free to ask them. Like, we're not, no judgment in this area. Like, this is very much your time to ask questions and ask for clarifications. And if you're not getting it, like, just keep asking the question, and hopefully we can find a way to represent the information and make it much clearer. Other questions? Right, we're going to see how well this goes by disconnecting the Ethernet cable. There we go. Another questions, I highly doubt that. So if you have a benzene with two halides and nitro group, it's going to be similar to what you did with. So if you don't have a parent compound, which we don't have, so if you had something like toluene or aniline or phenol, those would take priority. In the case of halides and nitro groups, they don't take priority. So you would name them as you would a traditional. Let's see, number 12. Let's see what version it was on my exam. Yeah. So it gives me a very similar problem on this end. So if we have two halides on a benzene ring plus a nitro group, so we get X, X, and NO2. So because there is no parent molecule, so in the case of something like toluene, that's CH3, it's something we would name it. We would ignore the functional group and just name it as toluene. If we had aniline, which is NH2, we would name it as something. We would name it as a dichloroaniline. If we had a phenol, it would be a dichlorophenol. But in this case, we don't actually have a parent compound. So we would kind of name this the way we would expect to name an organic compound. We start with the parent chain, in this case benzene. And we name the groups. So we've got the nitro. And let's say, for sake of argument, these are chlorine, so you have dichloro. So now we want to minimize the number ordering. So we can pick either one to be 1, but if it ends up, since the chloros come first, one of them is going to take a 1 position. And then we've got 1, 3, because it's 1, 4, or 1, 4. The question is whether this is 1 or this is 1. So if this starts being 1, then this ends up being 3 nitro. But if this ends up being 1, this ends up being 2 nitro. So it's a very similar strategy to basically naming any type of substituents on a hydrocarbon ring. Write out the substituents first in terms of alphabetical order. It'll tell you, by doing this, you'll identify which is the first carbon, and then you're just going to pick the ordering, which way you go around the ring, to minimize any numbering down the ring. But it's the same rules too. Nitro comes after chloro, so if you had fluoro, bromo, iodo, all those would come first simply because they're earlier in the alphabet. And for me, it was question 9. Nope. Still very German. Still want to make it as simple as possible. So it only benzene ring naming only gets complicated for me when there is a potential for a parent benzene derivative. So again, toluene, aniline, phenol, benzophenone, benzoic acid, all of those are more challenging for me because if you've got one methyl group, it's toluene. If you have two, I think it's xylene, and then you have to do orthometa-para. If you have a carboxylic acid, it's benzoic acid, and then if you have two, it's like dicarboxylic acid. So there is a pattern for the ones that don't have parent chain or don't have a parent benzene derivative. They're named just like everything else in IUPAC. But once you start throwing in the parents, one, the parents aren't necessarily named. In my opinion, they're not named intuitively. Like aniline is a trade name. If you email to a Tuesday, I might be able to get you feedback by then. I would probably say, yeah, email. The worst I'll tell you is that I'm just too busy. But yeah, the whole parent chain also gets thrown off because if you see more than one, it no longer gets named by the parent chain. So if you have more than one methyl group, it's no longer toluene, it's xylene. If you have three, it's something else. Aniline's the same way. If you have more than one NH2 group, then it becomes a di something. Fortunately, we kind of stay away from those. Hey, you're very welcome. For those of you in Orgo 1, we're doing the TLC lab this week. Do not be surprised if you don't get good results. Just going to put that out for you. It's a very frustrating lab. Not sure what we're doing in Orgo 2. All right, down to 2 concurrent viewers. What questions y'all got? Yes, so as I mentioned earlier in the live stream, the exams intentionally don't let you see what you got right or what you got wrong during the exam window. We've had too many issues with students. Basically, one will go in, take the exam, post the questions to Chegg, and then everyone else will look over the exam to figure out what the right and wrong answers are. So as of now, it should be open now that the exam window has passed. So while the exam window is open, the only thing you can see is your score. That's it. Once the exam window is over, then you should be able to go back through and see your individual question performance. Now, we are also actively phishing Chegg and Course Hero and websites like that, especially now that we're online. So anyone who might be tempted to post the solutions online, we are phishing those websites right now. You all get individualized questions and numbers. So as you can see with some of the previous questions, someone said, well, this is question 11 for me, it's really question 9 on my version. We can tell who posted what. That is actually an academic integrity thing. We can totally penalize your grade if you do post the solutions to websites like Chegg. But yes, please go through, check the exams. They should be visible now, and you should be able to see what you got right and what you got wrong. And if you have questions about that particular test question, so if you say, well, I did question number this, and I didn't understand what the answer was, feel free to ask about those in the live streams, and we can talk about how to work through those problems. With all my exams, you're allowed, with the exception of the final exam, you're allowed to go back through and see what you got right and what you got wrong. The idea here, especially with organic chemistry, a lot of this builds on itself. So if you're not getting it, you're not going to do well in successive exams. You're welcome. So yes, go through your exams, see what you got wrong. If you still got questions, feel free to ask them. We need to make sure right now the foundation is laid, especially if you're in Orgo 1. If the foundation isn't very good, you're going to struggle more and more as this class goes on. But if the foundation's pretty good for the test 1 material, you should be sitting pretty well if you're in Orgo 1, you'll be sitting pretty comfortably for the rest of the course. You're still going to have to work, but again, you're going to find a lot of this stuff comes back, and hopefully it's a lot easier to understand. For Orgo 2, we're going to focus on this aromatic dienes, trienes, all this for the next exam, and then we're going to start moving into different materials. But again, want to make sure you're understanding this material before you move on. The other thing is that no answer key is perfect. So if you do look over it and we conclude that, yeah, the key is wrong, this does happen occasionally with software like McGraw-Hill, you'll get the points back. Again, the goal here is to make sure you understand. And if you can't see them, let me know and I can figure out what's going on with the settings. But I think I set it up to definitely let you see what the solutions were after the exam date passed. Okay, let me check the McGraw-Hill website really quick then. So for so it's showing for this section, they're getting feedback 1 hour after the exam was due. So let's make sure that's true of all sections. But it's saying on my end it should be letting you view the exams now. No, it's good to let me know. So again, like I can tell you what it's saying on my end is it's saying that, oh, students can see feedback now. But let me make sure that this isn't just some unique, like maybe it's not assigned for all sections. So give me just one more minute. I'm willing to go with McGraw-Hill error on this too. Let's eliminate program error before we decide on student error. All right, so take a look at it again and see if it'll show you the information now. Yeah, just reset the permissions. So yeah, go ahead if you've got the ability right now, go through and check to see if it's showing you your exam and showing you what you got right and what you got wrong. The other problem with this, with my end, is also I can't really take the exam. I can see it. Let's see what's going on. All right, let's try this again. All right, Sam, we're going to see if I can get it to work for you. And if I can figure out how to get it to work for you, we'll assume it works for, I can get it to work for everyone else. Really? It is telling me I cannot update my own assignment policies. That's very strange. Well then. So I will take a look at this. But it's not letting me change anything about the exam. You see now? Okay, hopefully it's working now for some mysterious reason. Do you mind writing out the reactions for the other two molecules? I believe in the written out correctly, but I'm not sure. I can't see the results in either mine exam. Yeah, let me work on this after the live stream. It's not letting me do my own course, and that doesn't make any sense. So for 2-naphthol, your bicarbonate ion is going to protonate. Give you the OH2 plus and carbonate. And the carboxylic acids, you can write out the rest of the reaction. But that plus sodium hydroxide will give you R, will give you the carboxylate ion plus water. So those are the two reactions that take place during the separation of a 3-component mixture lab. Okay, I got it to work for one section. So 4102, you should be able to see your exam results now. Yeah, I know. $41.01, you should be able to see your exam now. All right, $41.36. Let's see if we can figure out what's going on with your exam. All right, 4136 Organic 1, you should be able to see your exam results now, and this leaves one more. So everyone who's in taking Organic 1 now should be able to see what they got right and wrong on the exam. Yes, Organic 2, y'all were already had that set. So yeah, so you're taking Organic 1, you should be able to see all your scores now. Hey, you're welcome. Okay, diagnose that issue, and I'll make sure it's already set up for the next. I'll make sure it's set up on the subsequent exams. All right, any other questions in the last few minutes we got? All right, if there are no other questions, we are into the test 2 materials. So if you are in Organic 1, we're going to start actually talking about alkanes now and organic molecules, how they're aligned in space in terms of conformations. We'll talk about some basic reactions and basic analysis. For those of you in Organic 2, we're going to start moving into diols, triols, epoxides, organometallics. So if you had me for Organic 1, you're over-prepared for organometallics because I didn't realize you weren't supposed to teach that till Organic 2. And this week, we're also going to start well, I guess we're into full swing at this point. So thanks to all of you who were able to show up. Again, we've got live streams Wednesdays, Thursdays, and Fridays. You are free to ask questions about the exams you've just taken. So if you have a question, you're not able to make it to a live stream, just shoot me an email and I can answer the question via the live stream. All right, I'll see y'all, some of y'all tomorrow, and the rest of y'all Wednesday.